Hello friends, in the last video we have talked about Brom's method to calculate the lateral load carrying capacity of a pipe. So let's take one example and apply Brom's method to calculate the lateral load carrying capacity of a pipe. So the problem looks like this in the example. On Brom's method, a concrete pipe same 30 concrete pipe of length 20 meter and the diameter of the pipe is 0.5 meter is embedded in sandy bed. The characteristic of the sandy bed are known to you. NH equal to 12,000 kilonewton per meter cube. That is the modulus of horizontal subgrade reaction, and the unit weight, total unit weight is 18 kilonewton per cubic meter, and the value of phi, angle of internal friction, is 35 degree. The allowable deflection of the pipe at ground level is 8 millimeter. So allowable deflection is also given to you. You will have to calculate the allowable lateral load carrying capacity using Brom's method. So you will have to calculate the allowable lateral load carrying capacity, that is QG. This we have to find it out. And the method to be used is going to be Brom's method. Depending upon the pile data solution, you can give it. Piles data. Already you know diameter, therefore the moment of inertia can be calculated. Diameter is 0.5 meter. So if you calculate the moment of inertia, all of you can calculate. So if I calculate it, pi d4 by 64 is the moment of inertia. This value comes out to be 0.00306. 0.00306 is the moment of inertia. So once you know the moment of inertia, find out the modulus of elasticity of the pile. So modulus of elasticity of the pile is given by formula 5000 under root FCK. FCK, you know, for M30 it is going to be 30 megapascal. So if you substitute, you get the value 5000 multiplied by under root FCK, and you can get the value of E as 27.38 into 10 raised to power 6 kilopascal. So this is how the modulus of elasticity. Therefore, you can calculate EI also. So if you multiply these two quantities, then you will be able to get the value of EI. It is 84,000.8. So you can get the value of EI also. So its unit is going to be kilonewton per meter square into meter force, so kilonewton meter square. So you can calculate EI. Therefore, you can now calculate the value of relative stiffness factor is given as fifth root of EI for the pile material divided by NH. So if you calculate it, so this gives you 1.475 meter. Therefore, you can calculate L by T, and L is 20 meter divided by 1.475. So L by T, a non-dimensional quantity, is greater than 5, and therefore it is a long pile. So chart for long pile, you should use it. Now, having got that it is a long pile, now from bending criteria, so first criteria is going to be from bending criteria. You can find out the value of QG, the lateral load carrying capacity of the pile. So first calculate My. You need to calculate yield moment My. How will you calculate? We know that My upon moment of inertia I equal to yield stress Fy upon Y. This implies that My equal to yield stress Fy into I by Y, that is the section modulus. So Fy is going to be 2/3 of the ultimate stress, so it will be 20. kilopascal. And the section modulus you need to calculate it. So moment of inertia is already known to you, and y max will be the maximum value of y will be d by 2, that is 0.25, and therefore let us calculate it. So if we calculate, we will get the value of my. So this is 20 into I divided by 0.25. This gives me the value of my, which is 245.4 kilonewton. So I am in a position to calculate the value of my. Having got this, now calculate a dimensionless quantity so that you can use the chart. Dimensionless quantity is my, the yield moment, upon gamma, which is 18, d4 into kp, where kp will be 1 plus sine phi is 35 degree. D is already known, therefore my is already known. So substitute all the values in order to get the dimensionless quantity my divided by gamma d4 into kp. So it is a dimensionless quantity, and let us calculate it. 18 this value is 59.1, no dimension. So on the x-axis, if you from the Brom's chart, now see the Brom's chart. So if you see the Brom's chart, you know that on the x-axis it is 59.1. So from chart, if you refer the chart, you will be getting Qg upon gamma dq kp, a dimensionless quantity, kilonewton per meter cube into meter cube. So it becomes kilonewton into kp. So this value, if you differ from the chart for 59.1, you will have E by D also. So this comes out to be approximately that is at ground level. E is 0, so E by D will be 0. So this comes out to be this one. Now, therefore, I can easily calculate Qg. Now Qg will be 25 multiplied by 18 into 0.5 cube into Kp. So let us all calculate this and see what value of Qg we get it. So 25 multiplied by 18 multiplied by 0.5 cube, then multiplied by Kp. So the total value of Qg is 207.5 kilonewton. This is one value you are getting. This is from bending criteria. Now what is the another criteria? Another is deflection criteria. So from deflection criteria, let us calculate. So from bending criteria, now The another criteria is deflection criteria. So one answer from bending. Now the second one from deflection criteria. What is the allowable deflection? 8 mm. The allowable deflection at ground level is 8 mm. That is the allowable deflection. Once we have the allowable deflection, here what you will have to calculate is eta. Because it's a sandy deposit, which is the fifth root, NH upon EI for the pi bit area. Already I have explained these things in the previous class. And NH is 12,000, EI is already calculated, 84,000. So 12,000 divided by 84,000, 1 by 7, and fifth root, so raised to power 0.7, x to the power 1. This. So then you will be getting the value of eta, and having got this value of eta as 0.6776. It is 0.67 76 is the unit per meter. So find out now eta L. L is 20, so multiply it by 20 and you will be getting the value of eta L. So if you multiply by 20 multiplied by this, it will be 13.55. So again, this is a dimensionless quantity, eta into L. Now having got this dimensionless quantity, from deflection criteria, you know for eta L equal to 13.55 and for E by L equal to 0 at the ground level, the value of, so for eta L equal to this much and E by L equal to 0, from the y-axis you can find out x naught multiplied by EI raised to 0.06, NH raised to 0.4, raised to 0.4 divided by QG into L. And if you refer the chart, this will be approximately for E by L equal to 0 and eta L equal to 13.55, or roughly you will be getting 0.2 approximately. This is the approximate value from the chart, from the Brom's chart. So from deflection criteria, I have got this value. Now x naught is already known to me. It is 8 millimeter. EI is already known to me. I have already calculated. NH is already given as 12,000. Length is already known to be 20 meter, and this value I have got it. So only unknown is QG. Therefore, QG based on deflection criteria needs to be calculated. Whole quantity divided by 0.22 into 20. So let us all calculate these values, and this will give you the QG value. So 8 millimeter, 8 into 8 minus 3 multiplied by 84,000. $12,000. 0.4 divided 0.22 into 20 meter. This gives me the value of QG equal to 70.1 kilonewton. So I am getting this value as 70. This value as 70 point this one. This is the second value. So first value was 207 from bending criteria, whereas from deflection criteria it is 70.1. Therefore, list of 1 and 2 lesser value should be always recommended as QG allowable. So allowable will be 70.1 kilonewton. Therefore, allowable lateral load carrying capacity equal to 70.1 kilonewton. This is the answer. So simply by using the chart, you are in a position to calculate the lateral load carrying capacity of the pile. Thank you very much.